Hello and welcome to my video, Division Facts and Helpful Hints. So, I did already record this video, and if you already watched it in the first version, you'll notice that the entire thing had absolutely awful resolution, and so you couldn't read anything that was going on. I'm not sure why that was happening. I believe I have it fixed. So, yeah, here it is. Redoing the video. So ask yourself, is it divisible by, and then you're asking yourself all these different numbers, 1 to 13. So first of all, is it divisible by 1? Yes, everything is divisible by 1. Okay, let's keep going. Number 2, is it divisible by 2? Well, all even numbers are divisible by 2, so does it end in a 0, 2, 4, 6, or 8? Number 3, do all the digits add up to a number divisible by 3? If it does, then it is also divisible by 3. Number 4, do the last two digits end in the number divisible by 4? If it does, it's divisible by 4. You can also divide by 2 twice. We'll talk about that over here in a bit. Number 5, does the last digit end in a 5 or a 0? Number 6, is it divisible by 2 and 3? If it's both, then it's also divisible by 6 because that is the prime, or that is the composite factors. Number 7 is the complicated one that honestly I don't really remember. I just kind of always use my calculator, take the number, divide by 7. But here's the rule: double the unit digit. Okay, double the unit digit. Then subtract it from the rest. Is that result divisible by 7? If it is, then so is the number. Number 8, do the last 3 digits end in a number divisible by 8? So the last 3 digits are kind of like the last 2 for number 4. Or I just think about dividing by 2 3 times, again, like this. Number 9, do all the digits add up to a number divisible by 9. This is kind of like the number 3, except we're dividing by 9 now. Number 10, is the last digit a 0? Number 11, all the way up till 9 times 11, the rule is, are both digits the same? There are more complex rules over here that you can find at this website for 11 and 13, but I don't remember those. I just use this. And then I divide. Number 12, is it divisible by 4 and 3? This is kind of like 6, where you just check 2 different numbers. Alright, the next thing to notice here is that there are a bunch of numbers that are prime. So if it is a prime number, those are the ones you're checking. Now, the 11 and the 13 are not usually ones that I would check, but they're good to know about as well. Okay, and you might have to check them depending on the question. The other thing to notice is that number 1 is a special number because everything is divisible by 1, and you cannot forget about that value. All right, so what numbers evenly divide the following numbers? We're going to just go through a bunch of different options, one at a time. So first, 1 and 84 divide it evenly. Secondly, it's an even number, so 4 and 42 divide it evenly. Secondly, if you add 8 plus 4, you get 12, which is divisible by 3. Therefore, you do 84 divided by 3 and you get 28. Keeping on going, 4, you can just take 2's number, 42, and check if that's divisible by 2, and it is, so we get 21. Given the fact that 21 and 28 are in there, and those are both divisible by 7, I can already check if it's divisible by 7 by doing that. But is it divisible by 5? No, because it doesn't end in a 5 or a 0. But it is divisible by 6 because it's 2 and 3. So that would be 60 plus 24, 14. Okay, and then 7, we're going to check 7 by going 8. We're going to take 4 times by 2 minus 8. So that would be 8 minus 8 is 0. So I believe that it is divisible by 7. Let's just try that out. I think that that's how that would work. Yes. So those are all the different numbers that evenly divide 84. You could keep going. This is the rule here. Second function, and then you square root the number. And so we should check 8 and 9 as well, since they are less than the number. Since 8 plus 4 is 12, and that's not divisible by 9, that is not the answer. 8 is 8 and 88, so it's not 84. So that is all of our numbers there. Okay, for 61, we go through the same process. First of all, we have 1 and 61. Then we check, is it even? No, so it's not divisible by 2. Then we add 6 and 1 together. We get 7. That's not divisible by 3, so neither is 61. If it's not even, it's also not divisible by 4. It's not divisible, it doesn't have a 0 or a 5, so it's not divisible by 5. It's not divisible by 6 because it's not even. And let's just check how far we have to go. Now we have to check 7 as well. So we do 1 times 2 minus 6. So we get 3 minus, other way around. 6 minus 1 times 2. I think I may have done it the wrong way around earlier as well. 8 minus 4 times 2 on the last one. Anyways, this is 3. Since 3 is not divisible by 7, it's also not divisible by 7. And now we can say it's a prime number. We don't have to check every number ever. We just have to check until the square root of that number. So we don't have to even check 8 because it's less than the square root of that number. Okay, let's continue on. So that's just a prime number. That's interesting to note. Okay, we've got 1 and 66, 2 and 33, 3 and 22, 4 does not work because this is not an even number. 5 does not work because it doesn't end in a 0 or a 5. 6 does work because it's 2 and 3. So what's 6? It's 11. Now we probably have to check 7 and 4. 4 doesn't work because, 7 and 8. 8 doesn't work because it's not divisible by 4. 7 might work, so let's check that. 6 minus 6 times 2, which is negative 6. That is not divisible by 7, so I'm going to say that it's not. Let's just double check that because I'm never confident about that rule, just using it. I'd have to test it a bunch more times. But anyways, we also have to check 9. So 6 plus 6 equals 12. So it's not divisible by 9, and this is our final set of numbers. All right, continuing on, let's go into some differently worded questions. Does 9 evenly divide these numbers? Well, all we have to do is add all the numbers together to see if that number is divisible by 9, and it is, so therefore, so is our answer. Okay, so if we add these numbers together, we get 11, so it's not divisible by 9. If we add these together, we get 18, which is divisible by 9, so we're good. Continuing on to the next one, we'll do the same sort of thing. We get 12, which is divisible by 3. We get 12, which is also the same thing, so it's divisible by 3. We get 5 plus 1 plus 8. We get 9, 14, which is not divisible by 3, so that one's not included. Okay, continuing on, which of these are divisible by 4? We just check the last 2 digits. Since 18 is not divisible by 4, neither is this number. Since 25 is not divisible by 4, neither is this number. Since 44 is times 11, that one does work. Since it has 0, 0, that one does work. Okay, 000 works for divisible by 8 as well. 84 is 21, so that one does work as well. Okay, continuing on to these, which are divisible by 5, which are divisible by 10. This one's divisible by 5, this is neither, and this one is 5 and 10. Okay, so if you're checking with your calculator, only check the prime numbers, because once you've checked those, you'll have an idea of which other numbers are available. Alright, I hope this video helps you understand some division facts and helpful hints. Good luck!